right? So next topic is n element uniform linear array, right? N element uniform linear array. So in uh, three classes back, right? In three classes back, I have discussed about two element array, right? Two element array. So two element array, we have seen equal amplitude and equal phase, and second one we have seen equal amplitude and unequal phase, right? So two element array, we have seen two different cases. One equal amplitude, equal phase, and second one equal amplitude, unequal phase. So equal amplitude, equal phase is nothing but broadside array, and equal amplitude, unequal phase is nothing but N5 array, right? So these things we have seen, right? And here, what is the procedure we have done? We have followed. What is the procedure? To draw the radiation pattern, we have um, determined array factor, right? We have determined array factor, and from array factor, we have determined maximum directions, and we have determined minimum directions, and we have determined half power point directions, right? So this is all a mathematical approach, right? So the entire thing is mathematical approach, mathematical approach, right? So this is all mathematical approach, right? So now, if array contains more than two elements, right? If array contains more than two elements, that is a 4 element, 8 element array, 16 element array, and so on, right? And so on. How to draw the radiation pattern? How to draw the radiation pattern using mathematical equations. Using mathematical equations, right? So therefore, to draw the radiation pattern or to determine array factor, right? To determine array factor for 4 element array, 8 element array, 16 element array, or any complex array, right? Or any complex array. Um, um, I'm going to discuss about n element uniform linear array, right? So array factor of more than two elements, right, is now I'm going to discuss, right, how to determine array factor of any complex array, right? So in the figure you can see, right? So you can see an array, n elements you can see, right? N elements, 1, 2, 3, and so on, n, right? And so on, n, right? So that means what? N element, right? So for example, if n is equal to 4, it is called as 4 element array. If n is equal to 8, it is called as 8 element array. If n is equal to 16, it is called as 16 element array. All the elements are spaced equally, right? All the elements are spaced equally. Here D, here D, here D, and so on, right? So on and so forth. Right? So the spacing between the elements, is equal, right? Just as 12-minute array, whatever the procedure we have followed in 12-minute array, the same procedure here I'm following, right? So there is no difference in the procedure, right? And here, let me let us say this is an axis, right? This is the y-axis or whatever it may be. There is no significance about it. This is x-axis and this is y-axis, and this is origin, right? This is the origin. So at the origin, antenna 1 is placed, right? At the origin, antenna 1 is placed, and to the right side of antenna 1, antenna 2, and at a distance d, antenna 3, and at a distance d, antenna 4, so on and so forth, up to NL, right? So earlier for 12-minute array, what I have done for 12-minute array, this is the coordinates x, y, let us say, and this is the origin, right? So in 12-minute array, for example, if we have considered two elements here, here one element and here another element, antenna 1 and antenna 2, and they are spaced d, right? Therefore, earlier what I have done with respect to the origin, that means origin as reference, right? Origin as reference, one element on the left hand side and another element on the right hand side. And EM waves radiated by antenna 1 and EM waves radiated by antenna 2. So this is ray 2 and this is ray 1, right? And makes an angle pi. So this is what I have followed for 2-element array, right? For 2-element array. But whereas here n-element array, I have changed the procedure, right? A little bit change here. At the origin, element 1 is placed, right? At the origin, element 1 is placed, and all the other elements are located on the positive axis, right? On the positive axis of x-axis, like this, as shown here, like this. All the antennas are placed, right, on the positive x-axis. And ray 1 is the EM waves radiated by antenna 1. Ray 2 is EM waves radiated by antenna 2. Ray 3, EM waves radiated by antenna 3, so on and so forth, right? So on and so forth. And this is ray n, right? Ray n, right? EM waves radiated by nth element. And this makes an angle pi, right? Here, this makes an angle pi. So it makes an angle pi, right? So now, same procedure, same discussion I'm going to make here. If you compare ray 1 and ray 2, right? Let us say this is our point of interest at point P, right? At point P, I'm going to determine array factor, right? At point P, I'm going to determine array factor. Array factor in the sense electric field. At a point P, my interest is to determine electric field, right? So therefore, what is electric field? What is the resultant electric field? It is the vector sum of field due to individual antennas, right? So electric field radiated by antenna 1 plus electric field radiated by antenna 2 plus electric field radiated by antenna 3, and so on, right? And so on. And ray 2, so this is ray 2 and ray 1, there is a path difference, right? There is here EM waves radiated by antenna 2 reaches point P first, right? EM waves radiated by antenna 2 reaches point P first, antenna 1 reaches later, right? Antenna 1 reaches later, right? It's because EM waves radiated by antenna 1 travel more distance, right? They will travel more distance to reach point P, right? Therefore, if you draw a perpendicular line like this, so this is a perpendicular line, right? So if you draw a perpendicular line like this, right? And we can say that, right? We can say that there is a path difference. So this is the path difference, right? So this is the path difference, and this is D, makes an angle pi. Therefore, path difference is D cos pi, right? Path difference is D cos pi. And similarly, you can take any two antennas. You can take any two adjacent antennas. The path difference is same. For example, between 2 and 3, antennas 2 and 3, right? And if you draw, right, if you draw a perpendicular line like this, so this is the perpendicular line drawn from antenna 3 to antenna 2, right? From ray 3 to ray 2, right? And it makes angle pi, right? Same angle, because point P is at infinite. When point P is at infinite, all these rays, ray 1, ray 2, ray 3, all can be considered as parallel, right? Therefore, this angle is pi. If this is D, if this is D, and what is this? This is D cos pi, right? So similarly, between 3 and 4, if this is antenna 4, and between 3 and 4, the path difference is D cos pi, right? D cos pi. So therefore, the path difference between any two adjacent antennas, the path difference between any two adjacent antennas is D cos pi. It is same, right? D cos pi, right? So therefore, what will get psi, right? So psi, here I'm writing phase angle, right? Phase angle psi is equal to 2 pi into path difference, right? 2 pi into path difference. So this is equal to 2 pi into what is path difference? D cos pi, right? And this is in meter, same whatever we have discussed in 2 element array, in the same, right? And this is equal to 2 pi by lambda d cos pi wavelengths, right? D cos pi wavelengths, right? And what is 2 pi by lambda? It is beta, right? So beta d cos pi, right? Beta d cos pi is phase angle psi. And here, this is one important point. Here I'm adding alpha, right? So this is alpha. Psi is equal to beta d cos pi plus alpha, right? And where alpha is the progressive, right? Progressive phase shift, right? Progressive phase shift. Alpha is called as progressive phase shift, right? That means progressive phase shift in the sense the phase difference between antennas 1 and 2. For example, phase difference between antennas 1 and 2 is pi. Excitation phases, right? Excitation phases, right? So if excitation phase difference between antennas 1 and 2 is pi degrees, then the phase difference between antennas 2 and 3 is also pi. 3 and 4 is also pi. 4 and 5 is also pi. That is called as a progressive phase shifter, right? So therefore, alpha is progressive phase shifter, right? For example, if alpha is equal to 0, if alpha is equal to 0, then it is called broadside, right? Broadside. If alpha is not equal to 0, it is n phi, right? Alpha is equal to 0 broadside and alpha not equal to 0, it is end fire, right? So because I am deriving an expression for array factor in general case, right? In general case, right? So general case in the sense what, from this array factor I can define broadside. From the same expression of array factor I can define end fire, right? But earlier what we have done for two element array, I have derived array factors separately, right? Broadside array separately and end fire array separately. For broadside array it is cos psi by 2, and for end fire array it is sin psi by 2. So these are the array factors I have derived separately, right? Equal amplitude equal phase, that is broadside array, and equal amplitude unequal phase, that is end fire array, right? So I have derived expressions for array factors separately for broadside array and end fire array. But whereas in an element array, right, in an element array I am deriving the common array factor which can be used to define broadside array as well as end fire array. So that is the reason why I have added the progressive phase shift here, alpha plus alpha, right? So if alpha is equal to 0 broadside and alpha is equal to alpha not equal to 0, it is end fire, right? So that is phase angle, right? And now electric field, resultant electric field at a point P, right? Resultant electric field at a point P due to an element array, right? Due to an element array. So what is the resultant electric field at point P? It is the vector sum of electric field due to individual antennas, right? It is the vector sum of electric field due to individual antennas, right? Now let us say, right, and here I'm considering equal amplitude, right? I'm considering equal amplitude, right? So because the only difference, the only difference between broadside array and end fire array is phase, right? So in broadside array in phase, in end fire array out of phase, right? In broadside array in phase, and in end fire array out of phase. That is only the difference. And amplitudes are equal in both the cases. In both broadside array and end fire array, amplitudes are equal, right? So now field radiated by antenna 1, this, right? Field radiated by antenna 1. So field radiated by antenna 1 is E1 e power j psi 0, right? Fields radiated by antenna 1 is E1 e power j psi 0, right? E1 e power j psi 0. And fields radiated by antenna 2 is E1 e power j psi, right? That means 0 psi, 1 psi, 2 psi, 3 psi, 4 psi, and so on, like that, right? And similarly, electric fields radiated by element 3 is E1 e power j 2 psi. And similarly, element 4, E1 e power j 3 psi, and so on, and so on. Element n e power j n minus 1 psi, right? N minus 1 psi, right? So therefore if here, right, if the field of antenna 1 is E1 in the sense what, E1 e power j 0 psi. So e power j 0, e power 0 means 1, right? E power 0 means 1. So therefore E1, right? E1. And field radiated by antenna 2 is E1 e power j psi. And the field radiated by antenna 3 is E1 e power j 2 psi, and so on, right? And so on. And n, right? N, we have E1 e power j n minus 1 psi, right? N minus 1 psi, right? So here I would like to remember one thing here. I will just compare, right? I will just compare with that of right. So here, let me explain one important one so that you can get more clarity, right? So in two element array, what I have done in two element array, right? In two element array, so this is the origin, one element on the left hand side and another element on the right hand side, right? And they are spaced a distance d, right? And ray 1 and ray 2, ray 1, ray 2, right? And this angle is pi, and the path difference is d cos pi, right? Path difference is d cos pi, right? So therefore, what is electric field radiated by antenna 1? It is E1 e power j psi by 2, right? And here E1 e power j psi by 2, right? E1 e power j psi by 2 and E1 e power j psi by 2. Let us say, right? Psi by 2. Why psi by 2? Why psi by 2? Because with respect to the origin, one element on the left hand side, another element on the right hand side. So therefore, psi by 2, psi by 2, right? Psi by 2, psi by 2, right? And here, one field radiated by antenna 1 lags. Field radiated by antenna 1 lags and field radiated by antenna 2 leads, right? So therefore, here minus E1 e power minus j psi by 2 and E1 e power j psi by 2, right? E1 e power minus j psi by 2 and E1 e power j psi by 2, right? So this is what. So therefore, field radiated by antenna 1 plus field radiated by antenna 2, right? But whereas in n element array, what I have done in n element array, this is the origin. Element 1 is placed at the origin, right? Element 1 is placed at the origin. Element 2 to the right hand side at the distance d. Element 3, element 4, and so on. Element n, right? So fields radiated by antenna 1, fields radiated by antenna 2, and fields radiated by antenna 3. This makes an angle pi, and the distance is d, right? So this is n element case. Just now I have explained, right? So this is what n element case, right? Therefore, the first element is at the origin, right? At the origin. Therefore, E1 e power j0 psi and element 2 E1 e power j 1 psi, right? 1 psi, and element 2 E1 e power j 2 psi, element 3 E1 e power j 3 psi, and so on and so forth, like this, right? Like this, right? So because all the elements are to the right hand side of the origin, right? All the elements are placed to the right side of the origins. Therefore, here psi 1 psi, 2 psi, 3 psi, and so on. But whereas in two element array, one element on the left hand side and another element on the right hand side. So therefore, psi by 2, psi by 2, right? Psi by 2, psi by 2, like that, right? On the other hand, right? Let me take another case, right? So here, let us say there are four elements, right? Four elements like this with respect to the origin. One element, and here another element, right? Let us say 1, 2, 3, and 4, like this. Makes an angle pi, right? And again here also path difference is d, and path difference again same, d cos pi is the path difference, right? So now here E1 e power j psi by 2 right? So this is the minus I by 2. So this is the electric field radiated by antenna 2, and similarly for antenna 1, E1 e power j psi by 2, right? Similarly for antenna 3, E1 e power j 2 psi by 2, and E1 e power minus j 2 psi by 2, like this, right? So if antennas are equally distributed with respect to the origin, right? If antennas are equally distributed with respect to the origin, like this we will write, right? So E1 e power j psi by 2, E1 e power j 2 psi by 2 means j psi, and if one more element is there, if one more antenna is there here, E1 e power j 3 psi by 2, right? Similarly, if one more element is there, right? Just a minute, right? So if one more element is there, right here, right? And this can be written as e power minus j 3 psi by 2, right? Like this. So therefore, the resultant electric field is sum, right? Adding all these, right? You will get the resultant electric field, right? So in alignment array, what we are doing is we are placing all the elements to the right side of the origin. So therefore, the total electric field E is equal to E1 e power j 0 psi, which is nothing but this is 1. Therefore, E1 plus E1 e power j 1 psi plus E1 e power j 2 psi plus E1 e power j 3 psi, and so on, right? And so on, plus E1 e power j n minus 1 psi. So this is the total electric field in an element. That is what we have done, right? So that is what we have done, right? So now I think you got a clarity, right? If origin is taken as reference, and if element is placed at the origin, so that difference, right? So now it is clear to you, right? And here we are not writing any negative values here, right? So because see, one more thing you might have observed here. So here, if elements are spaced in both the right hand side and left hand side with respect to the origin, here what we are doing, minus here, right? For the left hand side elements, minus we are writing, and for the right hand side elements, where we are writing plus, right? We are writing plus. But whereas here, no need to write minus plus, because all the elements are to the right hand side, and we are adding alpha, right? We are adding alpha, right? Progressive phase shift. Alpha we are adding, right? So depending on alpha, if alpha is equal to pi, then you will get minus, right? Minus to this element, like that, right? So you can find the difference, right? So therefore, the resultant electric field, right? Resultant electric field is equation 1, right? Resultant electric field is equation 1. So sum of all E1 plus E1 e power j psi plus E1 e power j2 psi, and so on, nth element. Nth element is E1 e power j n minus 1 psi, right? N minus 1, and where psi is equal to beta d cos pi plus alpha, and alpha is progressive phase shift, right? Now we need to simplify equation 1, right? We need to simplify equation 1, right? So to find out array factor, right? So how to simplify? So this is the procedure, right? So first step is multiply both sides with e power j psi, right? Multiply both sides with e power j side. So therefore, from equation 1, right, multiplying both sides. Equation 1, multiplying both sides with e power j side, you will get this one, right? So on left hand side term, e power j side, and e1, taking e1 common, right? Taking e1 common, what will get here, multiplied with e power j psi, And if you multiply this term with e power j psi, e power j psi plus e power j psi into e power j psi, e power j 2 psi, right? And similarly here, right? So if you multiply with e power j n minus 1 psi multiplied with e power j psi, so what will get? E power j n psi, right? E power j n psi. So that is what here you can see, e1 e power j n psi, right? So therefore now we have two equations, right? Equation 1 and equation 2. So therefore simplifying equations 1 and 2, right? Simplifying equations 1 and 2, we can get the array factor, right? So in what way we can simplify? This is one way, right? Subtracting equation 1 from equation 2, right? Subtracting equation 1 from equation 2, right? Equation 1 from equation 2, right? So that means what? So this minus this, right? This minus this, right? So therefore this minus e power j psi minus e. Therefore taking e common, we have e power j psi minus 1, right? On the right hand side, so this minus this, so therefore this term and this term will get cancelled, this term and will get cancelled, right? And um, this term, right? This term and what is the term before this? The term which is before this is e1 e power j n minus 1 psi. So therefore this term and this term will get cancelled, and we are left with e1 e power j n psi, and here e1, right? If you subtract equation 1 from equation 2, and the only terms will be left over are e1 e power j n psi and e1, right? So therefore taking e1 common, right? Taking e1 common, we have e power j n psi minus 1, right? So therefore e is equal to e1 e power j n psi, right? So this equation we will get. So this is the simplified equation we will get, right? And because this is the way to simplify series, right? Series type equations, right? And now array factor, right? Not normalized value, right? Array factor, and further simplifying, taking e power j n minus 1 by 2 psi common from this, right? From this taking e power j n minus 1 by 2 common here, right? Common here, and you'll get this. You can simplify that, right? You can simplify that, right? So like this, taking this common here, right? And you'll get this one. If you multiply it with this inside, you'll get again same, this one you will get, right? So therefore taking this common, we will get this one, right? And what is this? This is in the form of e power j theta minus e power minus j theta, right? So here what you'll get, this is not one. If you multiply it, right? So 2j, and in the denominator 2j, and you'll get this, right, as sine theta, right? Again in the denominator also, we have negative sign. So therefore again if you multiply and divide with 2j, and this 2j and the 2j will get cancelled, and we will have one more sign term, right? One more sign term. So in both the numerator and denominator you will get sign terms, right? Therefore sine n psi by 2, right? Sine n psi by 2 by sine psi by 2, right? So here sine n psi by 2, and here we have psi by 2. Therefore sine n psi by 2 by sine psi by 2, right? Now normalized value, right? Normalized value AF, right? Normalized value of array factor is equal to array factor divided by its maximum value, right? So maximum value of this, is n, right? Maximum value of this is n, because sine maximum value is 1, and denominator sine maximum value 1 by 1 is 1, and maximum value of e power j n psi by 2 is n, right? Maximum value of e power j n minus 1 psi by 2 is n. So therefore AF, array factor maximum is 1. So therefore array factor you will get this one, array factor normalized value 1 by n, right? 1 by n into sine n psi by 2 by sine psi by 2, right? So this is the value, magnitude you will get, right? So because magnitude of this one is 1, right? Therefore this divided by n, right? This divided by n. So array factor is equal to 1 by n sine n psi by 2 by sine psi by 2, right? So this is the final expression for array factor, right? Array factor of n element array, array factor of n element array, right? So this is the final expression, right? And from this, right, from this we will define broadside array, right? And we will define n5 array, right? So that we will see in the next class, right? So this is about n element array, very important, right? So in examination separately they will ask you to determine the array factor of n element array, right? Determining the expression for array factor of n element array, right? So that is the separate question they will answer, right? So if you require any clarifications, right, you can text me here in the chat box. You can text me if you have any clarifications, if you need any clarification from this topic, or if you want me to repeat the same topic also, I will repeat in the next class, right? So no problem, right? So because this is one very important topic, everyone should know, right? The procedure, how I'm deriving the equation, that procedure you should know, right? So with this I will close my session for today. Thank you very much for your patient listening.